the Neuron Robotics Console is the first point of entry to our entire application system. It is a pre-bundled, what's called a jar file, which is a compiled Java application that we wrote and we maintain internally. We put out a release of about once a month. Each release of the Neuron Robotics Console and all the libraries include an update of the firmware. Every month we not only do random bug fixes and performance increases, but we also go ahead and add features. Over the past year or so, we've added about double the amount of features into this device at no additional cost to any of the users. So we just keep making it better. So long as you have one of these devices and keep updating it, you'll just keep getting an increasingly better device over time. And I like that idea. So the first thing that it does is the device connects to the computer and comes up as a serial port. Different operating systems use different names for the serial ports. In Linux, they're called dev, TTY, ACM devices, or TTY-S devices. So ACM 0 would be this device. There are no other serial ports on this computer, so there are no other options in that drop-down menu. If, for instance, you were on a Windows machine, you'd see COM3, COM5, something like that. If you're on an OS X machine, it would be /dev/tty.usb.modem. Blah, 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 blah. A very long name, but the application does a very good job of detecting what the serial ports are and providing you options to select one. It's usually pretty obvious which one is your serial port. So in this case, there's only one, and it is TTY-ACM0, which is our device here. And you can go ahead and connect to it. And while it's connecting, you can see the center LED turns blue and flashes green. The flashing is communication being sent between the Java application and the device. If it's sitting there with a blue light, that means the communications link is established, but there's no data being sent over the line at this current moment. Down at the bottom of the DyIO, you see two bank LEDs. And what these refer to are the power source for the individual banks. So we have one bank over here and one bank over here. These LEDs are currently indicating orange, which means that they are the power for both of these banks is being sourced from the battery input, but since there's no battery connected, it's orange, which means 0 volts. Now, if I were to flip the switch for a particular bank, you'll notice it goes to green. If you flip the switch up to regulated, that means the power source for that bank has been switched to the regulated 5 volts that comes in off of the USB connector. Now, USB cannot provide enough power to power even one servo motor. So, built into this device is a protection circuit that will shut off the output to any servo motor that has a voltage on its rail that's invalid. Now, if you want to see what it looks like when you plug in a battery, take one of the included battery adapters and plug it in, and we get red LEDs. Now the red LEDs means we have enough power to run servos, which at this point now I can start plugging in servos and actually interacting with them. If I disconnect the battery, cables are always a little sticky. The LEDs go back to zero, go back to orange. So that's the basis of the hardware, or the power system. That is sort of the one and only way that you can get yourself into trouble, is expecting something to behave a certain way and it behaving differently. So understanding how that power system works will actually give you a better understanding of which devices should be plugged in for different power states, and if something's not working, possibly hint as to why. Now, as far as the rest of the channels go, you have a port for each possible device. There are 24 ports, and a port consists of a signal pin, which is denoted by the S, a power pin, which is denoted by the plus sign, and a negative pin, which is denoted by the negative sign. When I say power, I'm referring to the voltage relative between the plus and the minus. So in this case, there should be 0 volts between plus and minus, and the signal pin is independent of that. We're going to enable the sensor mode, which is the regulated power is usually used for sensors, so we turn it into sensor mode, and we plug in a sensor, which is a very simple switch. And in our console, we can look at that particular bank. You'll notice also that the LED in NR console has changed. Down at the bottom here, it has gone from orange to green. And let's take a look at port 0. So port 0 is currently set up as a digital input, and there are a bunch of options. You can have it a digital output. That would be for controlling LEDs or signals to any sort of chip device. You can use it as an SPI peripheral. The first 3 ports can be set up into SPI mode. You can have it as the input, the home signal for the encoder input, or the home signal for a counter output, which is used for stepper motors. Now, if we look at channels 8, 9, 10, or 11, or 12, 13, 14, 15, you'll notice an additional option on these. So I've clicked on channel 8 now, and you can see up here that when I go into these options, there's no SPI on this port, but it does have what's called analog in. That lets you measure voltages. Any valid voltage between 0 and 5 volts, it can actually measure and tell you what the voltage is so that you can read it from your application. So changing the mode of the port is as simple as clicking on this drop-down and selecting a different port or a different channel mode. Each channel has a variety of modes that are available to it, and NR console will display what modes are available on any individual channel. So as an example, we're going to go back to channel 0, and we're going to set it up as async, which means now when I press the button, the Java application will react. And to give you an example of the sort of speed, I'm going very, very quickly, and the Java application is keeping up with me. The time between pressing a button and an event happening in Java is about 3 milliseconds. So as you go from thing happening to your code being able to react to it, about 3 milliseconds for the information to travel up the channel, and then another 3 milliseconds to send a response back down the channel if you so choose. So that's probably good for the channel modes for now. So the other really interesting set of peripherals is what is called the PID configuration. And we're going to go ahead and tell it to display the PID configuration for us. And what we have here is a display that lets you select an input, an output, and connect them together in what's called a PID controller. And that refers to proportional, integral, and derivative control. The terminology may be a little bit confusing. It's more of a control theory terminology, but what it really means is you can use the input measurement of any one of these sensors to control the output of one of the outputs. And the standard use for something like this would be what's called closed loop control. So if you have a motor that just spins and a potentiometer that knows where it is in space, you can connect them together with a PID controller and control the motor in what's known as joint space. So you can actually control it so that it matches what the potentiometer is telling you. Now in this case, this would be an analog input on channel 10 and a servo output on channel 12. You set up the PID and you start it, and now you have the ability to interact with this controller as a device. And since my finger acts as what's called an open air capacitor, I'm actually generating voltages from the lights, and you can actually see that voltage as it's measured over time just by touching one of these pins. And that is the control input that this PID controller is currently reading. It could also be reading the input from something like a potentiometer. Let's see if I have one of those available. I think I do. What channel input is on 10? So let's set this up. And as you can see here, I have a very precise control over position for this device. You can see I can go down, I can go up, and this device will actually give us information on where this potentiometer actually is. So what it's doing is trying to tell the servo motor, which currently is not plugged in on channel 12, to try to match that position.